In this video I'm going to give an introduction to the Python list. A Python list can store a collection of data items with each item stored in an element. A list is an example of a sequence type. Another sequence type which we've already looked at on this channel is a string, and this is where you have things going one after each other in a structure. Other programming languages have arrays, and they are similar to Python lists, but they are not the same. Arrays are of a fixed size and hold the same data type in each of its elements. A Python list, however, is not fixed in size. It can grow and shrink on demand. The elements of a Python list can store different types, i.e. instances of different classes, in other words, objects, which is not possible with the arrays of other languages. Data stored in lists are more easily processed than data stored in separate variables. So the reason we have lists is we have imposed a structure upon variables, and that structure allows us to more easily process all of the various bits of data in the list. Let's have a look at how we can create Python lists. Here we can see an example of the creation of a list that stores prime numbers. And here you can see I've chosen the name of the list to be prime_list, and I'm assigning that this here. And you can see I've used square brackets, and within the brackets separated by the comma, you can see we have 2, 3, 5 and 7, all of which are examples of prime numbers. Now, I find it useful to have a schematic diagram to represent a list to help me better understand what a list actually is. And I like to show that as seen here. And you can see that I've chosen the name to be prime list, which was taken from here in the program. And what you can see is we have 2, 3, 5 and 7 all stored in their own area within the list. And here you can see the list has an index 0, 1, 2 and 3. Now, if we consider this list, this is an element, and this is an element that stores 2. This is another element, and this element stores 3. And if I come to the last one, this is obviously another example of an element, and this one stores 7. So we can see here we have 4 elements, and they each store their own copy of a prime number. Here you can see we have an index. And here's another index. So if I wanted to say what the name of this element was, we use this name. If I want to look at what the name of this element is, we use the same name. But to distinguish between them, we use the index, as you can see here. So this one, well, if we have a look at that, that's called prime_list. Then we have the square brackets. And in the brackets, you can see we have the 0, which is this index here. If I have a look at the next element, you can see that's got the name prime_list, but in brackets it's got the 1. And likewise, if I go on and look at the remaining 2 elements in the list, we can see that this one is prime_list 2, because that 2 is obviously the index. And here you can see we're going to have prime_list 3, because 3 is the index. Another way to visualize a list is shown here, and we simply have the list looking to be in a vertical direction. This is the first element, and you can see it's storing 2, and it has the index of 0. This is the last element of the list, and it has stored a value of 7, and it has an index of 3. Now, all of these elements will have this name followed by an appropriate index, and you can see that appearing here. Let's consider this computer program, and we know already that this is going to create a list that schematically we can view as shown here, and I've viewed the vertical one, not the horizontal one. And here you can see we have 4 print statements. So when this program runs, what we're going to see at the output is this. And you can clearly see that what's been printed out is 2, 3, 5 and 7, which are the contents of the elements here, 2, 3, 5 and 7. If we look at this line, what this has done, it's gone to this list, prime list here, and it's gone to this position, this index, because in the square brackets you can see we have 0, And of course that is choosing this index here, which means that this is the element to be chosen. And within here you can see we have 2, and that's what gets printed here. This is clearly going to the same list, but this occasion it's going to have in its square brackets 1, which chooses this element because that's the index, and of course this 3 is then outputted here. We come on to this one, more or less the same thing is happening, except if you look here in the square brackets we've got 2, which means this index position is selected, so this is the element selected. We get the content of that element, which is 5, and that's clearly output here. And finally, we're using the same list again because this name has been chosen, prime_list. And if you look at the brackets, we can see there's 3 inside, which means we go to this index position. This is the element that's been selected. We get at the content of that, and the content is transferred to the output here as 7. When I say transferred, I mean a copy of the 7 is sent from this to the screen here. Consider this computer program here, and it's almost the same as the one above. The difference is this line. Have a look at this line and compare it to this one. If we come back here, you can see that what I've got here is the word list. And then you can see I have 2 brackets. And within that, you can see within square brackets, I have 2, 3, 5, and 7. Now, you should be familiar with this syntax here. You see, what's happening is we're creating an instance of a class. The class we're creating the instance of is the list class. So this will be a name bound to an instance of the list class, and that instance will have 4 elements, and the elements will have the values 2, 3, 5, and 7. So when this program runs, what we need is the mental picture of what the list will look like, and it'll look like this, i.e. no different to what it was when we run this program and got this output. And here, well, we've got the same 4 print statements that we had here, so we would expect the output to be identical to this. And indeed, that's what will happen, and here we can see the output taking place. So we can see there are a couple of ways of creating lists. This is one way, which is a slightly easier syntax, and this is the other way. The advantage of this way is that it reminds us that we're dealing with objects, where this is going to be a name bound to an instance of the list class, and these here will be the values that are stored in the various elements of that list. Namely the 2, the 3, the 5 and the 7 you can see are here. Let's have a closer look at this computer program, and we can say that visually I like to look at a schematic diagram when I create a list, and that's shown here, and it's what we've already seen in this video to date. However, when we talk about a list as having its elements storing 2, 3, 5 and 7, in this case they all happen to be examples of integers, and in this case obviously they're all examples of prime numbers. What we need to bear in mind is that this view is a little bit simplified. I think it's important to know what goes on under the hood of Python when we create a list, because if you don't, you won't understand some of the nuances that will happen when you write some of your Python programs. What I would like to do is to introduce the following schematic representation of the creation of a list. You will often heard it said that everything in Python is an object. So when you talk about an integer, what you're really talking about is the instance of the integer class. And when you talk about a list in Python, you're talking about an instance of the list class. So I would like to take the schematic diagram here and alter it slightly so we can get a better understanding of the object-orientated nature of lists in Python. So when the first line of this program code executes, I like to think of the following. Here you can see we have got a prime list. It's got 4 elements. These elements have an indices from 0 through to 3, and when we assign 2, as shown here, to the first element of this list, what we have generated is an integer 2, an instance of the integer class. So I like to show that here, as you can see. And you can see that I've got a circular shape, which you will see that I've used elsewhere on this channel when I talk about objects. And within the element of the prime list, I have a reference. In other words, something will point to this object. And then we have the situation whereby this element is bound to this instance of the integer class. And if we now go on to look at how 3 is placed into the list, well, we generate an instance of the integer class that stores 3, and this element will have a reference that binds this element to that integer. And we can go on and we can show that the 5 is also bound to this element, and then the 7, well, that's bound to the last element in the list, as you can see here. Now, pragmatically, you can go with this view of a list. It'll do for most occasions. That's where you create a list and you say, well, I've got 2, 3, 5 and 7 stored in the elements of this list. However, that's okay, and it's no problems. You won't have any issues most of the time, but sometimes you'll come across something and you go, why is this not working? And it's because this is the setup here. You see, we have an arrangement where the element doesn't hold the actual value. What it holds is a reference to the instance that holds the value. So this element, which is prime underscore list square brackets 0 square brackets, has a pointer to this object, so this element is said to be bound to this object. And likewise for the other elements. Let's just choose the last one. You see, this element has got the name prime underscore list square brackets 3 square brackets, but it holds the reference to this object. In other words, this points to this object, and we are saying that this element is bound to this object. Let's consider this program again and look at the first line, and you can see that what we're doing, we're creating an instance of the list class. So this name will be bound to the instance of the list class. In other words, this is bound to an object. So the list itself is an object. So it is useful for us to return to our schematic diagram understanding of this straightforward program as follows. We have an object, and this object will have the name prime list, which is taken from here. Now within this object, what we're going to have is a 4 element list. Why 4 elements? Because here, if you look, there are 4 values, 2, 3, 5 and 7. So we will have this appearing, and this appears inside the object, which is an instance of this class. Now in each of these elements, we're going to have a reference to the 2, the 3, the 5 and the 7, where the 2, 3, 5 and 7 are going to be examples of integer objects, i.e. instances of the integer class. So what we can see is this. This is the integer object that this is responsible for producing, and we will have a pointer to it from this element, and that is said to be bound to the integer 2. If we have a look at the 3, well, we're going to have the 3 as an integer object, and this element is going to be pointing to it, so that's said to be bound to it. And we can go on to look at the fact that 5 is an integer, and we're going to see that that is an object, i.e. an instance of the integer class, and this element is going to point to it, and we can say that it's therefore bound to that instance of the integer class. And finally, this 7 is going to be an integer object, and this element is going to point to it, and that element is going to be bound to it, as you can see. Now when these 4 program statements execute, this is the output we're going to get. Now I think it's important to walk through the schematic diagram to get a feel for what's happening here. If we look at this line, you can see that this is prime underscore list, and in square brackets we've got the 0. Now this name is the name of this object, as you can see by this label. And of course, because here we're dealing with the 0 index position, we go to this element, and this element points to this object. So we go to this object, we take a copy of the two, and we send it to the output here. Now, these two lines obviously do something different, but of course they're using a different index position of 1 and 2. So I'll just have a look at this line, and you can see that this is prime underscore list, and in square brackets we have 3. So this identifies the name of the object, which is this name here, which means we're dealing with this object, and this 3 means we're dealing with this position. And we can see that this position is referring to this element, and this element has this arrow in it, which is the reference to the object here, because we can see they're bound together. So we go to the 7, we take a copy of it, and the 7 is passed to the output here, as you can see. Now you may be thinking, well, this is a bit convoluted. Well, it is, but this is what's happening under the hood of Python. On this diagram is a approximation to what's happening under the hood. Now, there's nothing wrong with you going with the simpler view of the list, but I would recommend that you have an understanding of both. And what we can see here is we have the list holding the references to the objects, and in this case the objects all happen to be instances of the integer class, whereas this, well, this is an object as well, and this is an instance of the list class. Now, why is it important for us to think of this as an object? Well, because it has lots of methods that come along with it, and we'll be looking at what those methods will do for us in later videos. So to summarize the schematic representation, here's the program, here's the simplified representation of the list that's being created, and here's the output. Now we can go, as I've already said, with this simplified version of our understanding as to what a list is, but we can also go with this view here, whereby we don't have the values stored as shown here, we have the values being separate instances of the integer class, and in the list we have the arrows, which are the references to where the various integer objects in this case are in the execution space. Now, if we look at this object, what we can see, we have all of these references, and the references are to these objects here, and all 4 of these are instances of the integer class. And this object we can see has this name, and this is the name that appeared in the code here. Now we can see we have 2, 3, 5 and 7, and they are instances of the integer class. However, if we're going to have object references here, it means that these can be any kind of objects. They don't have to be integers as shown here. So if we have a look at this diagram, what we can see is I've got an object and it's got the name list underscore name, and if we have a look, I've given it 4 elements again, but have a look what's inside each of these elements, and you can see we have a reference, no difference there, a reference appears within the elements. But have a look at this element, it's bound to this, and if you have a look at what this is storing, it's not storing a number that is an integer, it is storing a string, red. So what we've got here is an instance of the string class. If we have a look at this element, it's pointing to this, and it is storing 3.89. And this is an example of a real number, often referred to as a float. Here we can see that this element has a reference, but the reference this time is to this object, and it is in this case an integer, like the ones we've already been looking at in this video. If we come here, we can see that this position, this element is holding a reference, and that reference is pointing to this, so this element is bound to this, and if you have a look closely, you can see this is a list. So an element of a list can point to another list. In other words, a Python list can be all integers, it can be all strings, or it can be a mixture, as this is showing. Now with arrays in other languages, everything's either an integer, everything's a float, everything's a string, you cannot mix them up like this. But because in Python what the list stores are object references, and in essence an object reference is just an address that points to an object, that object can be of any type. And here we've got an object that's an instance of a string, this one's an instance of a real number, this one's an instance of an integer class, and this one is an instance of the list class. So here we have a list object pointing to an object which is itself a list. We can therefore think of a list as something that's capable of storing different types. They don't all have to be the same. Of course, the name of each of these instances, each of these objects, are as follows. The string object, well, that's going to have this name, list underscore name, square brackets 0. This one is going to be list underscore square brackets 1. This is going to be list underscore square brackets 2. And this one here is going to be list underscore name. And in the square brackets, you're going to have 3. So each of these are different instances, and they are instances of different classes, but they still have the same name because they have been referenced in this list here, which has this name. And of course we have the 0, the 1, the 2 and the 3 appearing in square brackets because we're picking up the indices from here. Now you may not like this view, so if you prefer you can go with the simpler version of the schematic diagram, which is shown here, and you can see that we have the list name and we have red as the string stored in the first element, 3.895, and this is an example of a list stored in the fourth element position of the list, i.e. list underscore name square brackets 3. Now this diagram conceptually represents a list in Python, and I've not shown anything stored in the elements. I just want to say that here we've got a 6-element list from index 0 through to index 5. Now with a list it can grow, so more elements can actually be added to a list, as you can see here. So we don't have to have it at a fixed size. If we want another element of the list, we simply can add it. We can also shrink a list, and we can show that conceptually as shown here, where the list is shrinking in size, i.e. we're removing the elements from the list. Now we'll be looking at the code that allows us to do this in later videos, but I wanted to introduce this concept here. A list is not fixed in size. It can grow and it can also shrink in size. Check out the supporting website for these videos. In addition, why not follow me on Twitter, as I issue a tweet every time I upload a new video.